In today's lecture, let us discuss a problem on how to classify a given data set based on certain attributes. So the classifier that we are going to discuss today is a name-based classifier. So we know what is the theory for name-based classifier. We'll be calculating what is the prior probabilities, and we have a formula for computing the classification based on the probability of occurrence. So let us look into the problem. So here is a 14 training examples of whether the people will play tennis or not based on certain attributes. So there are 4 attributes that is given to you. The first one is outlook. So the next one is temperature, humidity and wind. Now, what is the required attribute for playing tennis? So use the name-based classifier and the training data from this table to classify the following novel instance. So the outlook should be sunny, temperature should be cool, humidity should be high and wind should be strong. So this is the required attribute. Now we have taken 14 instances. What is the 14 instances? 14 different days which is having a different outlook. What is the outlook that is given to you? Sunny, overcast, rain. So these are the different forecast or the outlook that is given to you. And what is the temperature? It will be hot, mild and cool. And next we have humidity. It will be high or normal. Wind, it will be weak or strong. Now, what is the outcome? They will play tennis, yes or no. Now, look at the problem. So, what is the first step? We have to find the probability of whether they play tennis or not. Okay. So, we have 14 instances, and out of which how many days did they play tennis and how many days they do not play tennis. That is what we are going to calculate here. So this is the formula used for name-based classifier. So what is the outcome? Playing tennis. Play tennis is equal to y. Y is the outcome. What is x? X is the attribute or the feature that is given to you. What is the attribute? Outlook, temperature, humidity and wind. So that is x. So what is the formula? P of y, probability of occurrence, that is outcome, yes, into pi I is equal to 1 to n, probability for xi by y. So for different attributes, what is the outcome? So this is what we have to calculate. Now the first step is to calculate the prior probabilities. From the table we can see there are 14 different instances, and out of which how many days? Yes, they have played tennis. 9 days they have played tennis. So the probability of yes would be 9 by 14, and no, they have not played tennis, that is 5, and the probability of no is equal to 5 by 14. Now we need to find out what is the conditional probability, that is based on the attribute, what is the probability we have obtained. So there are total 9 instances, that is 9 days they play tennis, out of which the required attribute, outlook is sunny, 2 days it is sunny, so 2 by 9, temperature cool, so 3 by 9, and humidity high, 3 by 9, wind is strong, 3 by 9. So this is the required attribute for playing tennis. So we have obtained the conditional probability. Now let us see the probability for no. So we have the temperature, the outlook is sunny, no, 3 by 5, temperature cool, 1 by 5, humidity high, 4 by 5 and strong wind, 3 by 5. Now let us apply the name-based classifier formula. We have obtained the probability of yes and probability of no. Now let us apply that in the formula. What is the formula? P of y into pi I is equal to 1 to n, and for each attribute for outcome y, what is the probability? So we have the probability for yes and no. So probability for yes is 9 by 14, and for every attribute we have the probabilities and we have got them and multiply them. So when you multiply all of this, you will be getting a probability of yes is equal to approximately 0.00059. Now the probability of no is obtained a similar way. So P of no into the attribute for no, different attributes for no. So we have obtained them. So that is approximately equal to 0.00411. Now the step 4 is to compare and predict which is the outcome. Now probability of yes by x is equal to 0.00059 and probability of no is 0.00411. Now which is having the highest value? Obviously probability of no is having an highest value, so the prediction is no. So this is the outcome for this problem.